Okay, welcome back. In the last tutorial series, we did the delta loop, and it looked a little bit like this, and it was jolly good fun. We could go to 5 degrees off the horizon, if you remember last time. Our vertical was minus 5.7 dBi, and in some of these nulls here, it's minus 11. But out in the corner here, it's 5 dB better. It says in the middle at the top of your screen, gain is 1 dBi there, which is about 5 dB better than we are off on the vertical. And opposite the feed point, incidentally, we're 10 dB better than a ground-mounted vertical. On the 28.5 megahertz frequency, on a delta loop that is 10 meters off the ground. Now, I've never built a vertically polarized delta loop. So if this was a horizontal delta loop, a vertical delta loop, if we've got a tree here, can look two ways. You can either do it this way, another tree, or you can do it the other way around. And does it matter? You might just have one tree, and we can put a delta loop that way. And we put our feed point roughly a quarter of a wavelength, which will be here, and we want roughly 100 ohms for that. So that will be a piece of coax, a quarter of a wavelength long, less velocity factor, at 75 ohms. Then we could go from that quarter wave at 75 ohm and then join it straight to 50 ohms back to our radio, and you'd get a great match. We'll show you. To do it upside down or the right way up, I don't know. It's probably easier to do it the green way, okay, where you've just got the one tree and you just hold it out. And it looks, interestingly, a bit like a phased array. In other words, if you had two verticals, one there and one that side, they're roughly a distance apart. So you get a pair of phased verticals with a broadside pattern. We will have a look, see what the math says. File new. Right, we're going to hit our wire edit button. This time we need a Z, and we'll do ZY. So what I'm doing is I'm building it up here and down to there, and we're going to look through the middle. So similar to last time, I'll get a new wire. We're doing something across the bottom, which is too big, so I'm going to zoom in, because we know we want about, I don't know, what's that telling us? 15, it'll be fine. And then a couple of wires, one there and one there. 13. I'm going to zoom in a little bit more to give me some granularity, because that is probably too big. And the bottom wire is now 14 meters, and these top wires are 12.7. So I'll just make it a little bit taller for the sake of the maths. Now, down here, we need the 10 meter point. So I'm just going to draw a line, some random line, roughly 10 meters, about there, just to give me a gauge of where we should fit our feed point. So there. I am going to delete that wire now. With the delete button. There we go. And I'm going to split this into, I don't know, divide wire into 9 pieces. Yeah, there we are. So the top of wire number 10, we will fit our coax. Okay, top of wire 10. Geometry, wire 10, end. And we can gauge where that is. We want it at the beginning, look. Right, view that, that's fine. This time we want a roughly 100 ohm impedance, so it'll be optimization again, advanced, and we will click, well, we'll just type in roughly 100 ohms. OK, and then cancel. and we need it off the ground. At the moment, it should be sitting right on the ground. So let's lift it up about head height. 2 meters is 7 feet. And we're a little bit off, so we're gonna, because the SWR for 100 ohms says 4.74. I'm interested to know by hitting the plot button, SWR, and resonance button, where it is resonant, and it thinks it's on the 20 meter band. Yeah, that was my fault. We should remember to do 7.2 because I'm building this for the 40 meter band. 4.15 SWR resonance. It says it's best at about 7.6 megahertz. So if you remember my little trick, 7.6, and rescale this now for the 7.2 button by clicking this one here, wire scale. So that's a better 1.7. We have according to the maths, we've got an impedance of 166. In the field, it would be slightly lower, because if you remember, 0.2 of a wavelength and below, any wire, any part of the antenna below 0.2 of a wavelength will give a funny little impedance, but it won't affect the far field plot, which looks like this, which is incredible because we're currently by the sea, right? So that needs to be 5. Lovely, far field. Okie dokie. So if we come down to 5 degrees off the horizon, we've got a gain of 4.5 dBi on the delta loop. On the plane vertical was 5.7. So we are just over a dB. I hardly notice it actually. If we do a far field plot in colour, it looks like this. So in 2 directions, as a monobander now, you will get a little bit of extra gain, left and right, through the middle. Okay, so just to confirm, it's through the middle there. Right, so that's how to build a delta loop. You might think, oh, what happens if you raise that up? Well, that's what this tutorial for. You can then go and raise that up. Of interest, if you really had a massive tree, what would it do if it was higher? Probably not a lot. -5. Yeah, another dB. How about that? Okay, good. Next one, we will do... What are we doing next time? Hang on a minute. We've done a loop. We've done a vertical loop. We've done a dipole. Okay, next time we'll look at an end-fed. A lot of people have got an end-fed. I will show you how to build one in software. And since you've got one, you'll be able to go, oh yeah, mine works like that too. All right, so until the next time, enjoy your radio, keep playing with the software. I'll see you next time. Bye for now.